Hi guys, welcome to Learn Electronics Repair. This is a motherboard of a DJI Mini 3 Pro. It's not off our drone, or actually no, it is our drone now, but this one we were filming in the capital, Las Palmas, and a drone fell out of a tree, like a 50-foot or more tall palm tree, okay? Landed directly on the concrete paving slabs, and it was straight in front of us. So we did what any self-respecting drone pilot should do, and we picked it up. It turns out the thing had been in the tree for weeks, to be honest, and we don't know who it belonged to, but it obviously got stuck very high up in this palm tree with no way for them to recover it, and that's where it got left. Unfortunately, when it hit the ground, it suffered some quite severe damage. One arm was broke off, one of the front arms, not the where it normally breaks the arm, but the actual mount that fits onto the main chassis of it. But those mounts are fairly easy to get and they're not expensive. The other major problem is that the motherboard is damaged. Okay, everything else is possibly all right, we don't know, we don't have a remote for it, so if we're going to get this thing back in the air we need to pay for a remote. And the problem was is if we also got another motherboard, it was going to cost more than just buying a used drone complete anyway. So that's what we have. But I decided then, we were discussing this on the electronics channel, so that's the live stream we have every second Sunday with Det, Carlos and myself, and we just talk about all sorts of electronics and we have fun. Like this weekend we were proving how much voltage you can put on a electrolytic capacitor in reverse until it fails. So we do stuff like that live, yeah. And somebody asked if we were going to repair this, and I mentioned that I was actually going to try to replace the broken socket on the board. So I ordered some connectors. They're the right type of connector, and they're the right size, 24 pin. The problem is that they're the wrong gender. It was very difficult for me to work out from the listings what I was going to get. I ordered a pack of 10. In fact, you can see on here, it says quantity 10. This is the thing, whisk connector, 10 pieces, 24 pin male. Turns out I need females, okay, and there's 10 of them. Yeah, there's the 10 that arrived. so I have a lot of these, but I can't use them for this repair. Let's have a look at the actual damage to the motherboard and see what we can do with this. So let's look at the connector. This is the broken one, and you can see that half of it is smashed off. There's another one here, and if you look, this is a 24 pin connector, so you can see we have 3, 6, 9, 12 on either side. Okay, the other one, it looks like we actually have 11. That's because one is completely smashed off from here on both sides. But if you count the pads, or what's left of the pads, we have 3, 6, 9, 12. The problem is, you can see that at least 1, 2, 3, 4, 5, at least 5 pads have been ripped off altogether. And this one doesn't look too clever either. So that's what we have. Now it looks like that these pads that are ripped off, and we'll include this one, have tracks going this way. So 1, 2, 3, 4, 5, 6, and that one doesn't appear to go to anything. It might go to there. Okay, so the only hope of getting this thing flying again is going to be to fix this damage and then see if it works. Here's one of the connectors that I ordered. You can see it is the right type. It's just the wrong gender, as I mentioned. But if you look at the spacing of the pins, they do fit. I think you could see it there before I knocked it off, that they will fit. So what I'm going to do today is to see if we can repair this PCB damage. The way I'm going to do it is to use some real life connectors, or rather pads. I'll show you. So these are real life pads, a little bit tarnished, but you can see each one is like a little strip with a pad on the end, and we come in all different shapes and just little circular pads and so on, different sizes. So these are basically intended for repairing ripped off pads and tracks. I've never used these before. I bought them because it seemed like a good idea at the time. And I think it is a good idea. It's just, as I said, I've never used them before. But I think that you effectively use ultraviolet activated resin to stick them to the board, and then you solder the little stick coming from the pad to the remaining track on the board. And once they are soldered down and stuck down, you fit the connector. That's what I think we do with them, and that's what I'm going to try. Obviously, I need to remove the remains of this connector as well. Now, this motherboard, you can see, has a very large heatsink on, but I think this is soldered down. I mean, it's glued. I honestly don't know if that will clip off. It may clip off. Hard to say. I think what I'll try and do is actually remove that without removing this. Again, whether that's a good idea or a bad idea, time will tell. Just one other thing about this board, you can see it's damaged at this end. This is where it mounts. The heatsink is smashed as well, but we can get a heatsink, so that is damaged. Now you can see it's broken. I don't know if there are any internal tracks running in this direction, and the same on this one. I'm just hoping there aren't. You can see again where it's fractured there as well. So I'm just hoping that there are no internal tracks in here, but I don't think there are. I can't see any internal layers. It's probably easier if I just try and get this focused at an angle. This is extremely hard to focus properly, guys, and hard to see. I'll try the other microscope. I honestly can't tell you if there are any internal layers or not, so we're just going to have to hope for the best, I think, with this. Oh my, yeah. It looks like this is going to be a hiding to nothing, guys. I mean, I can see now under this microscope, just hold this steady, that we do have a multi-layer PCB in this area. But there again, if it was multi-layer, the layers would be everywhere. These are internal planes. It's quite possible we have a short between them. Well, guys, I've got it under the other microscope. I'm using a soldering aid just to hold it in place and keep it still. At this magnification, if I even touch the desk or breathe on it, it's going to shake around. But I'm sure you can see clearly inside that there are multiple inner layers, yeah, down in there. And the problem is that if two of those are touching, if it's a power plane, there may be even more than one voltage power plane in there, and ground, then it's going to stop working, even if it was working. We take this piece of board off and hope for the best. There's nowhere to mount the heatsink, so unless anybody has any really clever ideas, we ain't going to be able to fix this one, which is a shame. We can keep it for spare parts. I mean, we have another working one of the same model. We do have a few parts already, so you know, it's not a total loss, and it did fall out of a tree in front of us, so fair enough. I don't honestly think this damage is fixable. Mr. Guru, yeah, you're the guy on this sort of work. What do you think? Yeah, I mean, I'd certainly be interested to talk about it once again on the live stream. That's next one is going to be the last Sunday in August, yeah, so we can do that. But let's have a little play with these real life things. I've never tried them before. Let's have a little play to see how they work, and let's see if we can actually remove the remains of that broken socket and what the PCB is actually like under there if we do. I'm sure you will agree that the best way to learn skills like this, I've never done one of these before, is on something like this that you can't fix. Yeah, nothing to lose here, guys. So let's see if we can get this connector off. I'll add flux. I'm going to try and do it with this metal shield still on. I don't think it's heavy enough to make much difference to the desoldering. I'll get a nice new pair of sharp tweezers. And let's see if we can get this off. Sorry if there's a lot of background noise at the moment, guys. They're doing renovation work on the cafe next door. That might go on for a couple of weeks, who knows. I'm going to put this onto a metal tray just to raise it off the desk so I don't melt the mat, basically. People comment on my metal tray saying, well, actually, you're just adding a big heat sink, but this is kind of sitting on plastic feet. And to be quite honest, I heat the tray quite a lot as well. It's fairly thin. It actually acts in a way as a bit of a preheater because the heat gets underneath. This might actually be easier to do with preheater, but considering this is all plastic, I expect it's going to melt anyway, so I'm just going to heat it from this side and let's see what mess we end up with. Okay, I'll take it easy. I'll warm the area first. This will probably just curl away. I'm doing this just using the overhead camera. I'm not using any magnification other than that. There we go. Well, that's nice and warm. I may as well just clean up the PCB a little bit around there. I'll add a bit of flux to the braid. It always works better. Okay, flux on there. Let's just clean this up. I'm not dragging the braid, I'm just hitting it and letting it just soak up the solder. Okay, a bit on here. A bit of ISO. This is still quite warm. Just dry that out. We'll let it cool down and then we can have a good look under the microscope. But that looks pretty clean. That's come off to me. Well, guys, you can see the connector, or what was left of it, came off cleanly. And this is really interesting because I'm sure you can see that these tracks effectively connect from one side of the connector to the other side. So the 12 pins down each side effectively in parallel with each other. Yeah, if I just get the focus is difficult, depth of field, but you can see that pad which is still there goes to this one. This comes across to here, comes across to here. I'm guessing where there's like a little blob there is probably a via. This one across to here, that one, and so on. So repairing that shouldn't be too difficult. I'm even wondering if you only need this side soldered. Maybe the other side, if it goes to the same place at the other end of the cable, effectively you can just bridge them across. Yeah, just use one pad. I don't know if that's for reliability or for current, or it could be I've got a feeling this ribbon cable may split and go to more than one place, so maybe we can't do that. But the damage here is certainly repairable, I think. The problem, as I was just showing you, is on the other part of the PCB. Okay, so this should be quite easy to repair because of the fact that these just connect directly across. I'm just going to check to make sure I have a connection across that pair at the end, which I probably would have. This one looks like it might be slightly damaged, so we'll try that one as well. Let's just make sure they're all okay, in fact. So, just with the multimeter on continuity. That's good. This one, well, part of the pad is actually still there, but it's loose. That little bit there is actually loose. I might just actually take that off. This goes to the end of the track, but obviously there's no pad. Same with that one, no pad, no pad. This one is slightly loose, but that one's pretty good. This one, yeah. This one. This one. That's good. That's good. I was just catching the side of the metal casing, so I'll just check these again just to be sure. Yeah. Yeah. So they're all okay. We just have effectively 4 or 5 that we need to replace. I'm going to fix this then using these little real life connectors. You can see them here, and if we just take a look at the end, these are long enough to span right across from one side to the other. So I'm going to solder the tail onto this bottom end and put the pad where it should be, and I think that's all we need. I mean, this one I'll actually come across that, but the solder mask looks okay. I don't see any problem with that, to be quite honest. I could solder this one, I guess, differently by scratching away a little bit of this and then fixing it that way, but I think I'll just come straight down across here. I don't see it causing a problem. If this was scratched here, then maybe, but I could put some solder mask on first anyway if that was the case, but to me it looks fine. Okay, also I can test after anyway to make sure that there's no short there. So let's start fitting some of these on. I'll add a little bit of flux first because this will help to keep them in place. I'm going to stick them down with solder mask after they've been soldered as well. So just get a little bit of flux on here. Okay, not too much. I can spread it around a little bit with the brush. Okay, I think that should be fine. Okay. And I've realised by doing that, I've actually made it a little bit more difficult because I can't quite see where the pads go. So I'm going to clean that off again and just redo it. I mean, you know, guys, you try these things and you think, maybe, perhaps I should do it slightly differently. Okay, one moment. I'll just do that again because I think it might be a little bit easier for me. Okay, put some there, but not at the other end. Okay, so I have some flux on there. Let's get some of these little real life pads. So you can see I've peeled the copper back so I can get at them easily. I'll take one of these. These are the ones with the right shape, I think. Try not to bend it, just so I can just actually lift it up. And I think I'll start at this end. I'm right-handed, so it's probably better for me to start this end and kind of work my way along. I'll try and keep the focus for you guys. One moment. Okay, that's almost in place. I think just slightly outwards from there. That way a little bit, yeah. And then I'll just solder the tail end on. This might be easier with a smaller tip than the one I normally work with, but this may actually do it. I'm going to get a bit of solder on the end of the tip. If it's too big, I'll use something else this time. I'll now rotate it a little bit where I can work on it. Okay, let's see if I can just hold this in place. I'm thinking that I'm actually right-handed, I'm coming left-handed to hold it. That's not going to work very well. Or maybe actually it did, but the other end is tipped upwards. Okay. You can see, guys, this is just a bit fiddly. It's doable. It's just fiddly, yeah? Let's see if I can get this to stick. Nope, this time I'm definitely going to use a smaller tip. Okay, one touch. Just going again. I'll try the other way. I've not done this before, guys, you can see. It's slid downwards a little bit. I'm going to come in this time with my tweezers in my right hand, my favourite hand, okay. See, was that better? Yeah, for me that was definitely easier. Okay, once I've stuck these down with some solder mask, I can actually then just retin these a little bit without worrying about the thing coming off. So I'll go along here and just fit the rest of them, and then we can see how it looks. Okay guys, I'm sorry if that went out of shot. It's so difficult to keep this in shot for you when I'm on the sort of magnification. You can see that stuck on okay. In the end I went right-handed with the tweezers, left-handed with the soldering iron. I am right-handed naturally. So I'll now fit the other ones, and then we can hold these down with some UV solder mask, and then I can always re-solder any of them that I'm not happy with. But first of all, let me get them all fitted. Well guys, that proved really fiddly. When I cleaned off with the flux, I could see that this part was actually in the wrong place. I've taken it back off again. So I'm going to come up with a different plan with this. It was just getting too difficult to do the way I was trying. So what I'm going to do this time is I'm going to add a bit of UV solder mask across here. Not where the pads go, but just below it. I want to see where the pads actually should go. Don't want too much of it, that should do. This is the ultraviolet activated stuff. I'll just try to remove a bit of excess. Obviously I need enough to stick them with. So what I'm going to do is I'm going to get the pads into position. Hopefully this liquid goo will hold them down, and then use the ultraviolet torch, and that will set it, and that should stick them on. And once they're stuck on, then I'm thinking it should be relatively easy, relatively, to solder the other ends down. So let's see if this works. Okay guys, I found this is the easiest way, I think, at least. I'm not worried about these tails where they go at the moment. I'm going to stick this end of these all down, yeah. Just want to make sure I don't have a short anywhere. They're not quite level. This is probably a case where you should just leave it well alone. But you know, I'm always tempted just to try and improve it a little bit. I'll try moving the tail, yeah, like so. This one a little bit. Okay, I'm fairly happy with that. So let's get the UV light and hope for these will stick down. I've watched quite a few videos on people doing this, and the methods they were using didn't seem to work for me. Yeah, these are all fairly stuck down now, so the idea is I can scrape the solder mask off them later. So you can see we have the pads in the right place. Okay, having got this far, I'm hoping now I can just bend the little rat's tails over to the pads where they belong and just solder them on. Let's hope this works. To make this hopefully possible, I will add some flux. Okay, can't really put too much of this stuff as long as I can see what I'm doing. So I think I can see the first one. Which should go there, okay. Oh, okay. Okay guys, I've got the first three soldered down. This one is kind of twisted, but what's happened is the flux, I think, has caused the solder mask to soften up again and come off, and the other one just came off altogether from there, but we're so far getting in the right direction. So I'll clean this off again with some ISO and then see if we can fix the other two. Okay, so you can see I have three repaired now. This was kind of like all twisted and horrible and moving around. Probably best just to take that one off actually and just go again with it. But we only have two left to repair, so that's a result, yeah. Let's just remove the one that didn't go very well. That one, yeah, let's get that off my board. Okay. Yeah, so quite clearly I have three good enough, okay. The third one is slightly twisted at an angle, that one, but it's not going to shoot against these. Let's put two new ones on there. So I'll use the same technique again. I'll put some fresh solder mask on and then we'll stick the things down. We won't worry about it. We'll use UV and then we'll solder the other ends. Guys, there's people on YouTube make videos of these things that make these things look easy. Well, I'm telling you now, they ain't. Okay, this takes not the usual thing just of patience, but this takes a bit of determination, I'll tell you now. However, maybe we're getting somewhere. Okay. I think I have that one. Last one. Okay. I'm so a bit stuck. Okay. Let's turn it around. That's the problem with these, they stick to everything but what you want them to stick to. Okay. Trying to rotate this so I can get the right way around. Try that. Try rotating the entire thing. Nope, stuck on the tweezers again. I'm switching tweezers around, just trying to find the best way to move the damn thing. Okay. Maybe we'll have it now. Slide it in. Okay. Let's have a quick look. Well, they ain't touching each other. I mean, they're not quite positioned, but they ain't touching. That one's moved again. I'll try and stick this thing back down before it breaks off sooner or later. Okay. Try and move it by the tail. I have to say, guys, I think that's the best I can do with this. If I start, the more I mess around with it, then you get to the point where you wish I hadn't touched it, you know. They ain't shorting. Okay, let's see if we can fix them in position. Okay, let's see if we can fix these last two tails down. Well, it's not exactly quite flat, but it is in position. Better. The ends picked up a little bit. Let's see. Okay. I'll try not to get any flux onto the solder mask this time. I think that caused part of the problem previously. Well, I think I've got them tagged on. Let's have a look. I mean, they're not exactly flat, but what I'm thinking is now to clean the flux off, put some solder mask further down the whole thing, and then we can see if we can solder them better. So that one's on, that one's, yeah, they're on. Okay, they are definitely on, just not very good. Okay, so we'll clean the rest of the flux off this. I'll put more solder mask down the whole of these little sticks now, and then I'll try a final soldering. Well, guys, you can laugh at that if you like. I mean, all I say, if you think it's funny, try it yourself. If you've never done it before, yeah, try it yourself. This is really, really fiddly. I do have one bent bit there which I'm going to move out the way right now. Okay. I mean, this one is kind of on its side. That one's twisted at the end. The first three are pretty good, actually. Okay, let's see if this is good enough. Okay, so I'll give that a few minutes, just let it harden properly. We can scrape away a little bit at it to see if we have a good connection from one end to the other. I can cut off the spare bits of track that is sticking out at the end near to the metal casing, this bit. Okay. I don't have the correct connector, as we know, the correct gender, but we can see if it will fit with this little bit of soldering on there. And if it will, well, we can get the correct connector, but obviously we still have the problem with the damage through the multi-layers at the other end of the board. Well, as you can see guys, when I scraped away the solder mask, I managed to break this last one, so I've soldered another one, but on the plus side it's now flat at this end. Okay, and it is stuck on, even though it doesn't particularly look it, it is stuck on. So let's just check to see that we have good connections. Just get, yeah, that is solidly on, I can feel it. That one, yeah, that is solid again, and you can probably see it on this side, this is solid on. Just check the last one again. Okay, you see I have a break in that one just there. Okay, you can see it there. That's not going to be a problem to fix. This solder mask just dissolves with the ISO. I'm not sure it's supposed to do that, guys. Am I using maybe the wrong type or something, if you can suggest? Yeah, I'll just clean the ends off these, the ones that are stuck down. Just chop these off, see, that's not a problem. I can fix that one, but I just want to see if this thing will actually fit the connector. Oh, I'll just try one of the wrong type. Okay, so it does fit in place, but the solder mask there is sticking up too much to get it to sit flat. This stuff seems to come off fairly easily, at least with a bit of ISO. So I think probably I would just clean that off now with a bit of ISO. I think it's done its job holding everything down until I solder it. Let's have a go, just for the sake of making the right pig's ear out of this. Yeah, we're experimenting, let's have a go. Yeah, this stuff just effectively loosens up. I'm not sure that you're supposed to do this. Yeah, you guys can advise if you used the stuff before. I'm now moving these around because I really don't want to do. Okay, you can see what's happening. Bad things are happening. Okay, I'm confident enough that would work, apart from this broken one. Can we get this bit off here? Okay, so you can see what's happening. They're on there, yeah. Let's try a connector again. Okay, so after a lot of messing around, I think I can actually solder that on there. Obviously I need the correct connector, but I don't see why it wouldn't solder. I probably suspect I'd put a little bit of super glue on this end just to stop it lifting up when you unplug the connector, if I ever did unplug it again. But yeah, that basically did work. It was just a hell of a pain in the ass to do. Now, I don't know, and you guys can advise. I'll just show you what I'm using here. Although it basically worked, I think that was far more difficult than it needed to be. I mean, I'm not that bad at micro soldering, but that was just horrendous. So these are the little things I'm using to replace the pads. They say real life. Now, I've seen a few other brands of this, some on YouTube with them. I can't say I particularly saw this brand, but are these maybe made of thinner copper? I mean, these were cheap from AliExpress, and the whole thing's, they're not very rigid, yeah. And the ones I saw somebody else using wasn't wildly dark, but it was another one seemed much more rigid than this. And I'm wondering, A, are these El Cheapo ones just not very good? Number two, this stuff. This says mechanic. You can see what it is, okay. This just literally softens up and comes off with isopropyl. Is it supposed to be, or is this just rubbish? Again, I've seen people using it before, but I've never noted anybody having that particular issue with it, in case it was just like me. Yeah, maybe you shouldn't put ISO on after you've used it, but I'm a bit surprised at that. So do you think that was letting me down? Well guys, that was interesting, I think. I did say it was as much for experimentation as anything else. Never tried that sort of repair before. Hope I never have to do it again. But I guess if I do, I know I can. I'm just not sure I was using the right stuff, basically. So, over to you guys. Comments below. Yeah. Is it really just me, just no good at this sort of thing? Or is it really the stuff I was using was rubbish? Yeah. Okay, look forward to hearing from you soon. And I also look forward to seeing you all on another Weird Electronics repair video. Ciao for now, guys.